So anyway, this talk I'm going to go into the portable device architecture. I'm going to discuss our codec technology and how it works on different processor architectures. Then I'm going to discuss rights management and how encryption and decryption works on these devices, and then talk about how to achieve interoperability with different software applications that run on the PC so that the user, no matter which application they're using, can transfer the content to whichever device they just purchased. Okay, this is again to put everything in context. I'm going to be referring to the Windows Media Device Manager in this talk. That's the component of the format SDK that you'll be using on the PC when you're writing a jukebox that needs to talk to communicate with the device. It doesn't run on the device itself. The device manager is the software on the PC that is loaded by applications that need to communicate with devices. Anyway, and these other SDKs that we've gone through earlier in the day. Okay, so this slide is just trying to, get back. So these are just some of the shapes and sizes of the different devices that are out right now, and there are many more that are being contemplated, as I said. And I feel such excitement for the companies that get to build these things. Anyway, just stepping back a bit, what are the main customer requirements of a device? And the first thing is, so it goes without saying, they want to have a device that sounds great and that looks great and that it's fun to use. But they also want it to be low cost. They want to be able to play all popular formats. They don't want to be frustrated when they download a song from the web, or worse, they pay for a song and download it from the web and find that they can't play it on the portable player that they like to take with them. Then the next requirement comes sort of indirectly through the record companies. Record companies have been very vocal in saying that they're going to release their content in a protected format, and they want users, of course, to be able to experience the music wherever they go, but they don't want there to be rampant piracy. And so to reconcile these things, they want to have, they've created a consortium called the Secure Digital Music Initiative, and that lays out the protection that's required. And so in order for customers to be able to play the content that's released by record companies, they want devices that support rights management. And last, as I've already alluded to, customers want to be able to just plug the device into their computer and not have to go through a stack of manuals, and not have to buy a special software, and just have it show up in the UI of whatever application they're using. And we have some initiatives that address that. So this picture is a high-level schematic of a portable device. On a portable player such as a Diamond Rio or a Creative Nomad, or you may have seen like the Sony Bio, the music clip thing that looks just like a pen and plays MP3s and will play Windows Media and all the other devices. There's a lot of commonality in those devices. They're actually quite simple from a high-level point of view. There's some sort of a file system, or some sort of, if the device, unless it's all it does is purely stream data from the network, it needs to be able to cache content. And so there'll be some sort of a file system, and usually people are using FAT16. They may have compact flash memory, there may be a micro drive, there's some sort of storage on the device, and making sense of that storage and laying out the hierarchy of files is a file system. Then, kind of in the center, there is a player piece, which is sort of what we're just terming all of the central components of the firmware that sort of direct everything else. The player will read the files off the file system and then pass the bytes of the file into the WMA library for decompression and decryption. And the player, if the device supports multiple formats, the player is going to have to make a determination whether it's a WMA file or some other codec, and call the appropriate codec library in each case. And the point here is this box here, the WMA library, which contains the compression, contains decompression or compression in the case of a device that library is available from Microsoft, and you will integrate that into the firmware on the device and compile that and link it together with the, well, we supply it as a binary, but you link it together with the player. And the player is responsible for reading the file, unlike the format SDK on Windows, where before you would tell us the file that you want us to open or the URL that you want us to open. Here, you'll be just, the application is responsible for reading the file, and it passes in it doesn't have to interpret the bytes of the file, it just passes the raw bytes into the WMA library, and at that point, we decrypt it and decompress it and pass back uncompressed audio, and we also have methods that let you obtain title, song name, and the other pieces of metadata that I described earlier. The point is, with that metadata, the player can then drive the LCD display on the device, and it takes all the audio samples and sends them down the audio path through the equalizer to the digital to analog converter and out to the speakers. So, the one last thing is, when there's protected content, there's also going to be a license on the device, and I'll be explaining a lot more about that. But the player, just like it reads the file, if it's a WMA file, it's a protected file, it will need to pass in the license as well. And again, the player doesn't have to understand, you don't have to do any of the work of actually understanding how to do decryption or what the license format is. Just pass that in and we'll tell you whether the guy has the right to play or not. So, I want to just spend a bit of time on why we've seen just tremendous enthusiasm and interest in from basically all vendors, everybody making a device, to ask us how they can support the Windows Media format. And I want to just go through some of the reasons why it's been so popular on these devices. The first point is that it's very low cost. These devices are not going to have a high profit margin, and so anything that they can do to bring down the cost of the per unit cost is definitely something these companies are very interested in. And our pricing is very, very reasonably, and in many cases, we've negotiated a flat fee with the chip vendor. And so, in that case, the cost of the Windows Media decompression is included in the cost of the chip, and so there's no cost whatsoever to the OEM. They just have to send us an email, and we'll give them the library, and they can now start playing our format. The next point is that the implementation of the codec that we have, our codec is very efficient. It doesn't demand a lot of the megahertz of the processor, and it doesn't demand a lot of memory, and that leaves the OEM with a lot more headroom to carry out whatever product differentiation they want to have. They can have many other functions in the device in addition to the codec. The codec isn't hogging all of the CPU for its own decompression. So that's very attractive. The next point, as I mentioned before, is devices need the ability to play protected content. And we supply this right along with the codec, and it's all integrated and easy to do. So you get sort of two things for one there. So we're responding to this high demand, and we're delivering the codec as fast as possible on as many architectures as possible. And right now, immediately available, it's on x86. We've ported it to the ARM core, and so it's available on all the processors that use that core, such as the Cirrus Logic EP7209 chip. We've ported it to the MIPS cores, so this NEC chip, that series can support Windows Media. We've got it on SH3, we've got it on PowerPC, and we're working on a whole bunch more. So if you don't see it on here, I think we've even announced a few more. So if you don't see it on here, contact us and we'll let you know the status. So I want to just go through the statistics because, as I said, it's more efficient than other codecs. In particular, on this codec, we have some data right now. The clock speed, we use 29.6 megahertz. We use 19.7K of RAM on the chip, and this chip has 37.5K total. So we leave a lot of extra room there for other functions that the chip might need to do. So that number there has been very attractive. and we don't take a lot of ROM space. Okay. So I've been mentioning the Windows Media Device Manager. This is a feature, it's a technology that comes in the Windows Media Format SDK. So if you download the Format SDK from our MSDN site, you will get this. And what it provides is a single API that all apps can write to transfer content to any device. And we're saying, throughout this talk when I'm saying portable device, I really mean just any non-PC device, any device that you connect into the computer that you want to transfer content to. So obviously it includes car stereos, home stereos, and everything else. So this is gives you the ability so that many applications can talk to many different devices, just like nowadays you just take it for granted. When somebody writes a word processor, they don't even think about how to support specific printer features. They'll just write to the Windows API and call it through GDI and print things, and under the covers, Windows will take care of loading the appropriate drivers. So that's sort of an analogy to what we're doing here. This picture sort of illustrates that point. But actually, that was an analogy I said, just to be clear. These service providers themselves aren't actually drivers, and I'll get later into the talk where the actual drivers in the technical sense comes into it. But they're service providers that plug into the WMDM DLL, and an application on top will call in to WMDM and it will say a simple instruction like, transfer this WMA file to that device, and WMDM will query the device and find out which service provider to use and load it up, and will then pass the bytes of the file through to the service provider. And the service provider can then do whatever it wants in terms of getting the data actually out to the device. It could load up a USB driver, it could do something over 1394, it could do anything that it wanted and use any protocol that it wanted. There's no insistence on any particular connectivity here, because we're just saying to these device vendors that if they want to plug into all the jukeboxes and other audio applications out there, write one of these things, ship it on a CD along with the device, and when the user buys the device, they'll install this thing, or maybe they can download it from the web. Anyway, the user will get it, and then all of a sudden all their audio applications are enabled with their devices. When we ship WMDM, we're also shipping a default service provider that works with the file system. And you might say, well, why do you need a service provider for the file system? I'm not going to be transferring content to my C drive. That's not a portable device. But a lot of the devices have removable media that you can plug in, and when you attach it to the PC, those just show up as drive letters. And the media, if it's going to hold protected content, the media actually has to have a serial number. But you plug it into the PC, it has a serial number, and it looks just like a file system. And so to WMDM, it will load up the file system service provider and will transfer the content as if it's writing to a drive. And in the case of protected content, it will lock it to the serial number of the media. I just mentioned that because what's going to come up later in the talk is a device has to make a decision on whether it wants to look like a file system. If it doesn't look like a file system, then it needs a service provider so that apps who are using WMDM can figure out how to move content to them. So this slide is trying to make the point that it would be an intractable problem for every one of these applications to individually integrate and make sense of the APIs that every single device manufacturer was dreaming up for moving content to their device. So what we've seen tremendous acceptance of this technology because it simplifies everybody's life. These applications are writing to the application layer API of WMDM. And these devices are writing service providers that plug into the underside API of WMDM. And that way all of these can communicate with all of these devices in one fell swoop. The portable media these companies are all creating a serialized storage and that will be able to hold protected content that applications can transfer. When they move protected content, they can move it onto any of these instances of portable media, and it will be locked to that media, and they've exposed their serial number to WMS so that can happen. So I've been stressing the fact that WMDM just serves this function as a API abstraction layer to remove the application need to know anything about the details of the device. That's one of its functions. The other function is to handle all of the rights management issues, so that if you're starting with protected content that's on the PC and locked to the PC, in my earlier talk, I explained how the guy who publishes that content can indicate that one of the rights is he has the right to move to a portable device. So you have the right to do it, but how do you actually carry that out? You have to look at the license on the PC and make sure that he has that right, and then generate another license that works on the portable device and is tied to the serial number of the portable device. And handling all that is a bunch of work that the application, like the jukebox application, shouldn't have to worry about. So WM just takes care of loading up the DRM system and carrying that out. It enables the content to just, again, they just say, move this WMA file, put it on that device, and you handle all the other details. So we do that for you. So once the content is over, it is bound to the serial number of the device. So the serial number is actually used to decrypt the license, and inside the license is another key that's used to decrypt the content. So one thing to point out, just a clever aspect of this, is that the content has been encrypted and is on the PC. The content, the WMA file, which is encrypted, doesn't have to change at all when it moves to the portable device. It's just very efficiently, it's just moved over. The only thing that needs to change is the license, because the license that contains the key to decrypt the content needs to be altered. But that's just a small 100 bytes or so that needs to be changed. Along this chain, all the components that are loaded, in particular the service providers and the application on top, all of those have the potential. I mean, by default, they're seeing the encrypted data as it flows through, but they actually can call some APIs, and if they want to, they can get a hold of the unencrypted data. And to make sure that the system stays secure, we need to make sure that all those components are authenticated, that they have the appropriate, that they've signed the license agreement, and therefore that the DLLs that are being loaded have the required X509 certificates in that saying who they are, and that ensures that we don't just load up some spoofed DLL. So in order to make this actually work, you will need a certificate, and you'll get a library from us that will be compiled with the DLLs, and then it will work seamlessly with WMDM. So all of this, the point of all of this is to enable people to build SDMI compliant devices and build applications that can communicate with SDMI compliant devices. So I'm going to take a little detour on SDMI. A lot has been said, a lot has been written about SDMI, and I want to kind of stress it from a functional point of view. What they've done is there is a specification which has basically a series of functional requirements. There's some technology specifications in it, but primarily it's a set of functional requirements for what devices need to do and what's going to be allowed. And the point of it all is that users, when they buy content, they have a right. Copyright law allows them to make copies for personal use. And so in particular, it is entirely legal if you have purchased content to move it to a portable device and listen to it yourself. You're not violating anyone's copyright when you do that. So the challenge is to develop technology that permits what's allowed under copyright law, but doesn't permit indiscriminate piracy. And SDMI has a specification that lays out the details of exactly what that would be. So we've participated in that, and we have developed the rights management system in order to enable exactly this. And the point of it is, operationally, what it boils down to is, if you have a piece of protected content, you're allowed to move it to a portable device. And what you're not allowed to do is make copies from the portable device that can be used somewhere else. So you can't take the content off a portable device and move it to another portable device. and you also can't take it off the portable device and move it to another PC. And you also can't move it from a PC to another PC. But what you are allowed to do is have it on the PC and make copies from that first parent, if you will. And you can't make copies from the children on the portable devices. So that's the whole point. I mean, one other thing I should point out, you are allowed to move it to a piece of portable media. That copy on the portable media is bound to the serial number of the media. And then you can take that media and move it around from computer to computer, and it'll always play everywhere. But if you ever took the WMA file off of it, it wouldn't have a license to, if you made a copy and copied it onto the hard drive of one of those PCs that you moved it to, it would not play there. And we've demonstrated this technology. And we believe this is exactly what the publishers have been asking for. Basically, to get SDMI compliance, what people need to do is if they're building an audio device, they should support Windows Media, and you'll get the decryption code that you need together with the codec. If you're writing an application, implement it to call WMDM, and then go up to the SDMI website and look at their checklist and make sure that you haven't that you've complied with what they've asked for, and then you can contact them and find out about getting logo for your product. Okay, now I'm going to delve into, step back a bit from the rights management and go into the section on the actual connectivity between the PC and the device, because one of the challenges is to be able to move content seamlessly. And there are a variety of ways to do this. So I'm going to first take a detour into the file system in Windows and explain a couple things about that, then delve into some detail on USB transfers, and then talk about when you have to write a service provider. So this may be familiar to people who are like very well versed in the low-level details of Windows, but many people aren't. So I want to describe this. When an application wants to write a file, it'll typically call a C runtime function like fopen, or it'll call the Windows API the create file. And what that actually does is goes through a whole series of layers before any bytes actually get written out to disk. The first thing that happens is Windows will load up this thing called the installable file system, because Windows obviously supports many different file systems. A file system is what defines exactly how the blocks, how the directories are laid out, what file names are permitted, whether you only can have 8.3 file names, that sort of thing. That's all dictated by the file system itself. It's not dictated by the actual storage device itself. So the file system is just the software up here that is making these decisions about how to make use of the space. So depending on the volume that you've chosen to write the file to, the installable file system will load up the right modules here. And this thing, when it actually wants to write out a file, loads up. It doesn't know anything about the physical nature of the connection or protocol to the device. It loads up this I/O subsystem, which then talks to the drivers that have the low-level knowledge about how to send information out to devices. So, for example, SCSI, IEEE, 1394, so forth. What I'm going to concentrate on for the rest is this USB pathway. So I'm just going to remember this right-hand side of the picture to go here. So again, this is the same stack here. What's happening is for USB, the USB specification includes a section on how bulk storage devices should behave. A bulk storage device should basically has to respond to a read block and a write block command and a few others. But somebody who's trying to who's implementing a USB drive will implement a function that says read block 57, and it will then read the bytes and send all the bytes back. It doesn't actually these block commands don't specify anything about what the file system is. They're just purely low-level read and write blocks. So if you want to talk to a device that has a FAT16 file system on it over USB, the FAT16 file system will get loaded. Then a USB bulk-only storage driver will get loaded. The difference between these layers is this USBD component. This is the lowest level of USBD and the USBD stack on the PC. And this is all USB drivers make use of this. This is the thing that actually formats the USB request packets and communicates with the with the wires to send them out. So above that is the component that creates the USB block commands, that are these SCSI reduced block commands. And Microsoft is developing this and is almost done with it. And this is going to ship out in all upcoming operating systems, and it's going to be available down level on Win98. So in the future, it'll be very simple to implement a device that is bulk storage by responding to all of these block commands. So when we get over to the device, when the block commands come in, they have to actually be stored somewhere. And if the device is using flash memory, there is a component called the flash translation layer that is responsible for deciding where physically in the flash to actually write, block 57, as has been saying. So that's called a flash translation layer, and that's available from the vendor who's creating the flash. So this guy is handling, this guy just forwards out those USB, it strips off the USB request packets, parses it, figures out what's being asked for, and then calls the FTL to actually write something to memory. Then, on the playback side, when it comes time to make sense of everything that was written out, there needs to be a file system component on the player that can make sense of all the directory structures that have been written out. So there needs to be the same file system implementation, obviously shrunk down and ported to the architecture of the device. But it needs to be there so that the player can read back those files. And then we get back to the earlier picture, so the player then calls the codec, which is the library you'll get from Microsoft, and then sends it to the audio path. So this is one option where all of the software on the PC side is implemented by Microsoft, and there's just standard USB bulk storage on the device. And if you plugged in such a portable device into your computer, you would see a drive letter come up, and it would be something you could drag files to, and it would look like just like a USB drive, even though it was capable of playing music. But what's been happening for whatever reason, people are going ahead, device manufacturers are going ahead and making proprietary USB drivers. Because, as I said, that mass storage driver in Windows hasn't shipped yet. So what's happening in that case is they're just inventing whatever protocol they want to, or they may actually continue to use the USB bulk storage protocol. I'm going to link that over here. But the point is that what's showing up over here is not a driver that plugs into the file system stack the way a normal drive would. So if you plug this kind of device in, you won't see a drive letter, and it won't appear to be files to the operating system. And what this vendor has done is just surface some proprietary I/O control codes that the application can call and use to make the file go out. And that's fine if there was only one application, but as I've been stressing, there are going to be many applications that need to do it. So what we want to have happen then in that case, we want to support both modes, both where the device looks just like a file system and we could run through the whole normal file system stack, but also the possibility that, a very completely valid possibility that the device, for whatever reason, wants to do USB or some other connectivity all on its own. In this case, they'll write a USB driver of their own, and they'll also write a WMDM service provider that calls in and makes exactly those device I/O control calls that I explained before. So the whole point of the jukebox up here is completely immune to all of those sorts of decisions, and even if this device in the future decided it's going to be a file system, this application won't have to change at all. And so, right now devices are all shipping with their own drivers, USB drivers, and my only point here is that if you're shipping your own driver, you'll also need to create your own service provider so the WMDM will know how to talk to that device. So this is as I mentioned before, this is the point that I'll go back through this whole pathway here. The service provider, the driver, and so forth. All of these components, if they're going to be able to see any unencrypted data, they need to be authenticated. And so, so for that, they need a certificate, a WMDM service provider certificate, and we will issue those you contact Microsoft, you sign the license agreement, and then you will issue the certificate, you compile that into your DLL, and then WMDL will load it up. Okay, so that's what I have. I want to stress again to go here and get the format SDK, and email. I should put an email address here up here because it's not in the slides there. Email wmsdk@microsoft.com to get information about the specific codec ports that are available, and for any information about how to build the portable devices.